All right, 9.5.2, we're doing binomial expansion. So a binomial is a two-term polynomial. So for example, 5x plus 2. And when we expand it, it means that this binomial is being multiplied by itself some multiple number of times, maybe exponent of 5, and how that expands. So for example, if that was an exponent of 2, you already know that you can do 5x plus 2 twice and then FOIL it, and you get 4 terms, right? You got 1 something plus something plus something plus something. Well, this formula, the binomial theorem, is going to tell us what goes in each of those spots, no matter how big that exponent gets. So FOIL we can do easily. That's just a 2. But as soon as it gets to 4 or 5 or 6, it gets pretty messy to just multiply that out. So having this formula helps us able to do that. You'll see this formula, which looks a lot worse than it is, and we're going to go through how to do that. And it's really not that bad, but it looks bad. It looks like, how am I going to memorize that? But it's actually, you don't really have to memorize it. You can just kind of understand it, and it comes out. I'll show you how to do that in a few minutes. But you do notice that these numbers are the n choose k numbers that we did in the last section. And that's why they're called the binomial coefficients, because when we expand the binomials, these coefficients, like in this one we have n choose k is 2 choose 0, and then 2 choose 1. Oh, yeah, actually, I think it doesn't have 4 terms when you do the expansion. Anyway, yeah, because these 2 terms combine. Anyway, I'm sorry, I got off track there. So those will be our coefficients. So I'm actually going to have you watch the example from the textbook first, and then I'll have you come back here and I'll show you the way I do how I remember this formula without having to memorize the formula. You know me, you know I don't really like to memorize anything, so I just try to understand the formula, and I can kind of get a system down so that I can do the formula without having to remember the formula, which I'll show you how to do after you watch example 3. Example 3 is kind of funny in your textbook. You'll see it's just a little misplacement in the text, a little typo-ish. That usually comes at the end of the example, but on this one they just put the link to the recording in the wrong spot. That's how it came up on my textbook anyway. If you're on the computer, that might look a little different. But go ahead and watch this video. If you can't find the link after the example, then just scroll up and you should be able to find it there. But it's around page 731. So push pause on my video. Go watch example 3, and then come on back here and we'll try one together, and I'll show you my way of doing it. Okay, so hopefully you did example 3. Actually, before I show you my way, I'm going to have you go ahead and try to do it on your own. Try to do the same way you just saw in that video. Go ahead and expand that. You can pause on my video, see if you get it, and then when you come on back, and we'll see how you did. Okay, so when I expand this, first thing I do is think, how many terms am I going to have? So I'm going to draw a blank for each term. So if we're going, this is really a sum of all of these things. So sum going from 0 to n, that means I'm going to have n plus 1 terms, and my n here is a 5. So if n equals 5, I'm going to have 5 terms in my binomial expansion. So, I'm sorry, 6. So n plus 1, right? Because I have the n and then I'm starting at 0. So n plus 1 terms, so that's 6. So 6 terms. 1, 2, 3, 4, 5, running out of space, 6, and let's see, what color should I use next? I'll use purple. Okay, so now I look up here, my sum is always a product of A and B. And what's A here? A is x and B is the positive 3. So A equals x, B equals positive 3. And each element or each term in this sum is A to some power plus B to some power. Everything's A times B. So I'm going to do an A times B, and then we'll go back and put in the exponents in a little bit. But all of these are A times B. Oops, I'm sorry. They are A times B, but we know our A and B, right? A is x and B is 3, because we're looking at this one specifically. So it's x to some power times 3 to some power. X to some power times 3 to some power. X times 3. X times 3. And I'm going to go in and put my exponents in a little bit. Okay, next thing is my exponents. So for my exponents, I think, okay, I'm looking for every combination of exponents. Remember, this is n minus k and this is k, so those are always going to sum to n equals 5. So whatever the exponent on the first term is, I'm going to have the two exponents are going to add up to 5. So for the x, for the first term, I start with n minus k. That first term is n minus 0. So that's just the 5. So it's n. On the first term, it's n. And then I have n minus 1, and then n minus 2, and then I'm just counting down from n. So 5, 4, 3, 2, 1, and then 0. And on the second term, the b, I start at k. K starts at 0, so I start at 0, and I count up. So 0, 1, 2, 3, 4, 5. And you'll notice the exponents on all the terms, the sums of the exponents is 5. Because one of them's n minus k and the other one's k. And then the only thing I have left is the coefficient, which I'm going to do that one in orange. So that's that n choose k that we did in the last recording. So n choose k, the first n choose k is, remember, k goes from 0 to n. I have n for all my n choose k's, all my coefficients, I have n in the top. So I'll go ahead and write n for all of them. Whoops, not n, sorry. I know what n is. N is 5. So I'm going to go ahead and write the 5 for all of them. And then in the bottom, I have k, and k goes from 0, 1, 2, 3, 4, 5. So I choose 0, then I choose 1, then I choose 2, then I choose 3, then I choose 4, and then I choose 5. Now this part I don't really want to usually write, but I just want to point out that this term is the term that I get when k equals 0. This term is when k equals 1. This term, k equals 2, and so on. So you can see how the term that I have written matches this for that k. When I plug in 0 for k, I get this term. When I plug in 1 for k, I get this term. So in that case, k goes from 0 to n. Okay. Now, I don't normally write those k's. I just wanted to point out that that's what those 6 terms are. That's the k going from 0 to n. Okay, but now it's time to evaluate those things. Okay, so I'm going to start with my coefficients. So my coefficient for 5, choose 0. I can either use that formula that we learned in the last section, or you can think, wait a second, I know a study tip that says anytime I choose 0, there's only one way to do that. There's only one way to choose no one. So that is a 1. And then the 5 choose 1. If I have a group of 5 and I can only choose 1, I don't have to use the whole formula. I could, but I don't have to, because I know if I have a group of 5, then I have 5 choices. So that one's just a 5. I also remember this study tip that says there's going to be some symmetry here. 5 choose 0 is 1, but also 5 choose 5 is 1. 5 choose 1 is 5, which means 5 choose 4 is also 5. 5 choose 2. Let's see, if I have a group of 5 and I want to choose 2 people, that means 1, 2. So I have 5 choices and then 4 choices. That's 20 choices so far. But order doesn't matter, so I'm going to cut that in because 10 of those are just repeats. So I know 5 choose 2 is actually 10. So I can think about the choosing, or I can go back and use that formula in the last, like we did in the last section. And if that one's 10, then this one must be 10 too, because there's that symmetry. Okay, so now we got our coefficients. And now I want to add in, or I should say simplify our x times 3's. So I have x to the 5th times 3 to the 0 is just 1. And then I have x to the 4th times 3 to the 1, which is x to the 4th times 3. And then I have x cubed times 3 squared, which is 9. And then I have x squared times 3 to the cubed is 27. And x to the first power is just x, and 3 to the 4th power is 81. And x to the 0 is 1, so I don't have to write that. And then 3 to the 5th power is 243. So simplifying all of this one more time, 1 times x to the 5th is just x to the 5th. 5 times 3 gives me the 15 x to the 4th. 10 times 9 gives me 90 x cubed. 10 times 27 gives me 270 x squared. And 5 times 81, that one I'm going to need some side work here. 405. And then the last term, there's no x, so that's just 243. All right, and that is my final answer. So there's my expanded binomial. So if I take x cubed, x plus 3, and I write this out 5 times and just multiply it by FOIL, just distributing over and over and over again, that would be exhausting. But if I did it and then I simplified, I would get this. And that concludes the binomial expansion, 9.5.2.